The NEA is a design and make task worth 50% of the GCSE qualification in design and technology. The written examination makes up the remaining 50%. The starting point for this task is the contextual challenges which are set by Eduqas. The contextual challenges are explained in detail on slide 4. The task amounts to approximately 35 hours of work. Some of the work can be carried out at home, but the manufacture of the final prototype or product must be completed in school under the supervision of your teacher. The NEA is worth a total of 100 marks. Your teacher will assess the work in the first instance, but it will be externally moderated by Eduqas. There is no set format for this task. It is up to you, the candidate, how to organise and present your work. A suggested approach is that all informal work such as research and investigation, initial ideas and discussions around modelling and testing are recorded in a sketchpad, and the more formal technical details are recorded in a portfolio. It is also up to you how to interpret the contextual challenges and the direction you take in developing your ideas. The design journey you take in developing your ideas is personal. The portfolio of evidence that you submit for assessment is outlined in this slide. The information listed here will become clearer as we move through this walkthrough. All initial work can be recorded quite informally in a sketchpad, for example, with the more formal details recorded in a presentation portfolio. An important aspect of this task is the modelling and testing of ideas, which should be evident throughout the task. You must keep evidence of all the modelling and testing that takes place. If it is not possible to keep all the evidence and the test pieces, then photograph them and record the photographs as evidence in your folio. This evidence should be submitted for final assessment alongside the final product or prototype. Eduqas will release 3 new contextual challenges each year. The contextual challenges are starting points to get you thinking about design problems and possible solutions. The challenges are not prescriptive, they are open to interpretation. Your peers may have totally different ideas to you, and that is good. It means that your project will be different and yours will be personal to you. Your teacher will give you the contextual challenges. It is worth considering all 3 contextual challenges, but you might find that one holds more interest than the others, and that's fine. The important thing to remember is that when you identify a number of design possibilities in the early stages of the task, analyse 3 contextual challenges might enable you to do this more easily. The needs and wants of the potential user is an important and ongoing theme throughout your task. Think about different groups within society and consider their needs and wants. Try to identify a problem that you can address. It is useful to have a real person in mind for this task that you can engage with throughout this design and make exercise. A real client could be on hand to make suggestions that will help you overcome issues you may face or may point out some strengths in your designs. Other tasks you can do to get you started include product analysis, research into new materials, processes and techniques, but whatever you decide, focus on the problems you have identified. Avoid unnecessary activities that do not add value to your task. Look at the work of designers and other practitioners. This can be a useful tool. However, if you do this, make sure it is relevant to your task, your personal journey. Iterative design is a cyclic process that focuses on modelling ideas, testing them, and analysing the results to refine the ideas. Iteration is about repeating a process, sometimes several times, to get it right. This is an ongoing process that leads to the development of a successful outcome. It could mean rethinking an idea and a starting point again, or it could allow you to tweak something that didn't quite work effectively first time, but will help you to move your design forward. Think, test, reflect. Trialling and testing can throw up unexpected results which may prove beneficial, something you haven't thought of, and being rewarding for taking a risk. Avoid fixating on one idea, be open to other possibilities. Many ideas will also be rejected during this process. Trialling and testing could focus on the whole product as a concept model or parts of a product, for example, design details, construction methods, or materials. It is important that you reflect on all the trials tests you conduct and make sure to record your thoughts. The iterative design process is not linear. Research and investigation and design development work side by side, one informing the other. Trialling and testing of ideas might identify the need for further research, regardless of what stage you're at in the development of your product. The opportunity for multiple starting points exists. You can start the task, you can start by modeling an idea or analyzing an existing product and that you hope to improve on. Start at a point that feels right for you. This slide proves a visual image of how the iterative process of design works in principle, from exploring design possibilities in the first instance, thinking about design possibilities alongside some early sketching and modelling of ideas, the practical exploration of ideas through to a final solution that meets the needs of the users. Testing and analysis becomes more focused as development progresses towards a final solution. A banded mark scheme will be used to assess your NEA work. The 100 marks available are divided up into 5 assessment strands as shown in the first table. Note that the bulk of the marks are for generating and developing design ideas and making the prototype. Consider this when allocating time to your various tasks. The entire GCSE course is developed around assessment objectives, AOs, skills that you need to demonstrate in order to gain the qualification in design and technology. AO1, AO2 and AO3 are explained in the table. Don't worry too much about these. The evidence you produce that fulfills the assessment criteria will ensure the requirements of the course are met. The marks awarded for each assessment criteria are subdivided into bands, 4 to 1, as shown in the second table. Each band has detailed descriptors of what is expected at each mark range. Your teacher will assess your work and decide which descriptor best fits your work. The mark will be awarded according to the evidence you provide. If all the descriptors have been met, then a high mark is awarded. If several points are missing or not sufficiently detailed, a lower mark is awarded. As you progress through the NEA, refer to the mark scheme. Look at what is expected in the assessment criteria, as well as what you might need to do to get a specific mark. The next few slides will outline the evidence you need to provide in order to meet the requirements of each of the 5 assessment criteria. Please note that your work does not need to be laid out according to the 5 assessment criteria. The iterative process requires an integrated approach, meaning research and developing and testing ideas, for example, should occur simultaneously. For this assessment strand, you must provide evidence that the contextual challenges have been analysed, whether that is 3, 2 or just 1. This could be presented in the form of a spider diagram, for example. The critical point is that a number of possible design tasks are evident. It may be that analysing all 3 contextual challenges will make this more straightforward. It's your choice. Keep an open mind when looking at design possibilities. Fixating on a preconceived design idea at any stage may hamper your design thoughts. There are a number of research activities that could help at this stage. You could look at a range of existing products similar to your intentions, look at their strengths and weaknesses, analyse them, and try to explain what you've learnt. You could conduct a detailed product analysis on one competitor product and look more closely at the materials and the construction processes in that example. You could also deconstruct it to find out how it was made. Use this information and model and test a few ideas. Modeling ideas includes annotated sketches. A useful design tool is to look at the work of other professionals, how they work, and how their work is inspirational, and only if this is relevant to your design task. Keep the research you conduct relevant. Avoid unnecessary activities that do not help. You will need to identify your target market. The needs and wants of the user is a continuous theme throughout this task. Try to keep that in mind. It is useful to have a real person or persons as your client, a family member for example, who might offer opinions as you progress through this task. You must show evidence that you fully understand the task ahead. Make sure you evaluate and analyze the information you gather, as this is referred to as your designs develop. This section can be recorded informally in a sketchpad. This is the banded mark scheme for the first section of the assessment criteria, identifying design possibilities. It is marked out of 10. Read through the descriptors for each mark. Words such as detailed, thorough, and effective, highlighted in red here, are used to describe the work needed to gain the marks in the 9 to 10 band, whereas little, basic, and partial are used where the work fits the descriptor for 1 to 2 marks. The difference in the vocabulary used here is clear. There is an obvious increase in the level of difficulty and detail expected at each mark range. Note that if only one design opportunity has been identified, your final mark could be placed in the lowest band. It's good to familiarize yourself with the mark scheme. It can be used in 2 ways. Firstly, as a reference to check what is needed. Secondly, for you to assess your own work as a self-assessment or possibly a peer assessment piece of work with a friend. Use the column on the right-hand side to tick off everything that you feel has been sufficiently covered, or to identify what else might be needed. Some way into your design journey, you will need to write the final design brief. This is not to be confused with the identification of a number of design possibilities earlier in the task. The design brief is a statement of intent, what you intend to design and make to solve a specific problem you've identified. It must reflect the analysis of all the research and investigation that you carried out. Reference should be made to the intended user and their needs and wants. The design specification should be set out with all the factors you believe are critical to the success of the final product. It's up to you how many you include, but any that you do should be reflected in the analysis of research, investigation and testing, and early ideas. Make sure to include measurable and objective criteria. Measurable criteria could be important sizes, materials or construction methods, aesthetic features, weight, mass, or functional aspects. Details that you can physically measure the final product against to gauge its success or otherwise. Note that measurable criteria should be arrived at through your investigation and testing, and not just appear. Link measurable criteria to something that you have found out. The needs and wants of users needs to be clear. Describe how you intend to address this. There are a number of ways of setting out your specification. Your teacher will have guided you through this in the course of your studies. Key terms such as form, function, materials, aesthetics, sizes, etc. should be evident in any good specification. It is suggested you include the design brief and specification in the formal portfolio. Refer to the specification to direct and inform your decision making as you progress through the task. This is the mark scheme for the second band of assessment criteria, developing a design brief and specification, also marked out of 10. The same format is used as seen in slide 9. Familiarise yourself with the mark scheme. The mark awarded will be dependent on the level of detail you provide. The same descriptive vocabulary is used throughout the mark scheme. Note the words highlighted in red for the top and the lower mark ranges. This section is about your design ideas and how they develop into a final solution that you intend to make. This is where you need to demonstrate that you have followed an iterative design process. Think, model, test, reflect. Your initial sketched ideas could be quite basic. Get the ideas down on paper quickly. Annotate them to explain. You could use a model or a mock-up or a small simple prototype for a few ideas using paper or card, for example. Your starting point could be a model of an idea, not a sketch. This is your choice. Think about shape, form and function of the product. You can refine your ideas later. You will reject many ideas, that's to be expected. Focus on what works and what meets the specification criteria as well as the needs and wants of the users. Keep all your models and test pieces, if possible. You can also photograph them, paste them into your sketchbook alongside the analysis. This should be used as ongoing development throughout. You must provide evidence of decision making. This could be explaining why something is being rejected or developed. As your design improves, sketches and test models should become more detailed and refined as you move towards the final solution. For example, you might need to start refining specific parts to improve the function or performance of the product. These slides outline the different types of modelling techniques you could use. Initial sketches need to be analysed and then tested. And this is early, low fidelity modelling. Use card and other scrap materials to generate a model for testing. This will allow you to see if the idea has any potential and where any problems might need to be solved. This iterative approach will continue until you arrive at what will be your final idea. The introduction of CAD is a useful tool to scrutinize the potential concept once lots of unwanted aspects have been rejected. CAD can be time consuming, so only use this method for good ideas. CAD can quickly lead to CAM modelling and rapid prototyping, which can be used with the target market for testing and feedback. In the formal portfolio, you will need to provide a high-quality detailed pictorial drawing of the final prototype, how it will look while it is made. All appropriate views should be included. It can be hand-drawn or presented using CAD. It does not need to be annotated. You will need to include all the technical details needed to manufacture your prototype. A dimension drawing is essential. You will need to follow this when you make your prototype. The sizes should reflect those listed in the design specification. Other details include tools and equipment necessary for manufacture, as well as specialist processes and materials, and any critical settings for machinery. This is the banded mark scheme for the third of the assessment criteria, generating and developing design ideas. Notice this is marked out of 30 marks. Familiarise yourself with the mark scheme and refer to it as your design and make task progresses. The mark awarded here will be dependent on the level of detail you provide. The same vocabulary is used throughout the mark scheme. Notice again the words highlighted in red for the top and the bottom mark range. Note the second bullet point down in each of the mark ranges refers to a social, moral and economic factor. These factors could be covered within the research and investigation, but are awarded marks in this section. Make sure that any reference to these factors is relevant to your task. A logical sequence for manufacture and the finished prototype are worth up to 30 marks. The logical sequence must show the steps needed to make your final prototype. It is a forward plan of instructions that someone else could follow to make the same product identically. The sequence must also include an achievable timeline for manufacture. Approximately 35 hours are allowed for the entire design and make task, so the time allocated to make your prototype should be a proportionate amount of time for the task. The sequence should also include quality control checks to ensure your prototype is of the highest quality. You might also indicate how you will test the success of the final product or prototype. It is up to you how you present the sequence for manufacture. You could use a flowchart or table. More importantly, include all essential details. The sequence could be placed in the formal portfolio. The finished prototype is the culmination of all the hard work you've done so far. It should be of a high quality, show precision and skillful use of tools and equipment. Take care and pay attention to detail for this manufacture. Think back to the testing and trialing that you carried out earlier. Refer to what worked well. Hopefully you will have learnt from your own experience and be able to put that into practice now. The finished prototype should function as intended. It should reflect the design specification criteria and answer the design brief fully. This is the mark scheme for the fourth assessment criteria, making a prototype, marked out of 30. As with the other slides showing the mark schemes, familiarise yourself with this one and refer to it as you make your final prototype. The mark awarded will be dependent on the quality of the final outcome and whether it functions as intended. A poorly made finished prototype may not fully function as intended, so a lower mark could be awarded. The same type of descriptive vocabulary is used in this part of the mark scheme, but focuses on the quality and accuracy of the final outcome. The words highlighted in red differentiate between the top and the low bands. Consideration would be given in this section to the ongoing analysis that occurred during design development as well as the final evaluation of a product's fitness for purpose. This evaluation is like a report. It is critical, objective, and an appraisal of the product's fitness for purpose. You must consider whether your final prototype meets the design brief and the specification criteria. You must explain how or why it does or does not meet the requirements. Be objective. There may be perfectly valid reasons why something didn't work out as intended. This is not wrong, it is part of the process, but explain how this could overcome faults. You must provide evidence of testing your product. Take photograph of it in use. If you can test it in situ, where it would realistically be used, then do that. If not, simulate a situation. Record what you learn from this. Engage with the intended users. Ask them to test it. Seek their opinions. Include a response to any feedback you receive. Suggest further modifications based on any observations you make or any feedback you receive. Consider how you could further improve your prototype. This could be presented as another design page or as written notes. This is the mark scheme for the final part of the assessment criteria, evaluating the prototype, marked out of 20. As with previous mark schemes, familiarise yourself with this one too. The bullet points listed will support you in writing the final appraisal of your prototype. That concludes this walkthrough for Eduqas GCSE Design and Technology NEA. Hopefully the slides and information provides you with a clear and justified vision of how and where marks are awarded and the evidence of activities that will be required. Remember, there is no set format. It is impossible to get this wrong. Your design challenge will take the shape that it requires. Just make sure that your work reflects the assessment criteria as discussed in this resource. Any questions about anything covered in this walkthrough, make a note and discuss with your teacher at the next opportunity. Good luck.